Hey everybody, this is Larry. This is the 11th day of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, and join the Discord channel. So let's go to today's problem, which is subsets. So usually, or recently, I've been doing an explanation part before the live coding, but this problem is easy enough that I think I'm just going to go straight into explaining it and then coding it in one take. So yeah, let me know what you think, and let me know if you're able to find this problem. But yeah, so basically this is a subset, and you're trying to return all possible subset, which is the power set. There are a couple of ways to do it. You could do it recursively, which I recommend as a beginner. In Python, you could actually use ILLER tools to help you get the power set, which accomplishes the job, but you know, like you should get the practice, and that's not really a good practice. So yeah, so what I'm going to do for this set plus for this stream, however, is to kind of do it in a different way. I'm going to try to do it in bitmask and explain it in a way and go over the pluses and the minus. And yeah, let me know what you think about that. But what is a power set, right? Power set is the set of numbers, or it's the set that contains all the possible subsets of a given list or something. And in general, the 2 to the n, where n is equal to the length of the whatever thing that you're power setting. So the 2 to the n number of power sets, right? And you could do the math to figure out why, but basically that's pretty much it. And the reason that, you know, to show the math a little bit is that let's say you represent stuff with binary, meaning that, okay, let's say that, you know, we have five elements, 1, 2, 3, 4, 5, right? And we put it in a Boolean array, but instead of a Boolean array, we use zeros as false and 1 as 1, right? So then that means that if we have 5 zeros, that means that no numbers are here in this current set. And then let's just take another random-ish one that's okay, something like this. That means that 1, 3, and 4 are in the set, right? So that's kind of a way to represent that's a way to represent whether a number is in a set, right? In this case. So some assumption is that because this is going to be 2 to the n, that this answer will have 2 to the n things. That means that you cannot do better than, well, 2 to the n, right? And that also means that there's certain assumptions, meaning that, you know, if n is equal to 30 or something big, well, then that means that there are a billion elements, right? Well, a billion elements is going to be really slow no matter however way you're going to do it. So we can assume that that's not the case. But in any case, and also just to fill it out a little bit, if these are all ones, that means every numbers are in the set. Something like that. Every number is in the set. Yeah. So then now, that we represent whether a number is in the given set with zeros and ones. Well, another way to kind of sum this up is then, well, now we could just convert this to a binary number, right? And in that way, you could see that this is 0, and in here it is 31, I think, something like that, right? So you convert it to binary and then just look at it bit by bit, and that's what we're going to do today. So now let's call it mask in range of 2 to the n. So let's just say 2 to the n, right? So then now this will go from 0, 0, 0, 0, 0, 0 to 2, 0, 0, 0, 0, 1, and then it will also go to 0, 0, 0, 1, 0, and so forth, right? So that's kind of how a power set works. Okay, so given that, what's next? Well, now that we know that this generates every possible subset, now we just have to convert it back to numbers that we can use. So, okay, that's 7 answer away in this case. But also that means that we have to look at bit by bit whether that number is 0 or 1. So there are a couple of ways to do it. But let's just say for offset is in range of n. If one offset, shift to offset, and this number is basically, so this number starts with, well, 1 is just 1, right? And the number of offset that you shift will, so with 0 offset it's just number 1, with 1 offset it'll become 10 because you shift it, and then with 2, the offset is go to 2, it becomes 100, with offset it goes to 3, it becomes 1,000, right? In binary, obviously. So basically you have this kind of thing, and then that's when you use the AND operation with the mask. And what that is saying is that let's say you have some mask 1 1, so, and you're looking up this mask. Oops. So what's going to happen, right? And let's say that the offset is 3, like in this case. Well, what's going to happen? Well, if the mask has a 1, this will return the bitwise function. This will return this, which is not 0, right? And conversely, if this is a 0, then you just get 0. So the way that I write it, though, there are a couple of ways you could write this, but find your way that you're comfortable with. So if this is greater than 0, that means offset, the offset number is in the set. So that means that okay, so now we have a current array is equal to this thing. So if this is in the set, then we want to append the offset, or, well, in this case it is the numbers of offset, the index of incef of numbers, right? And then that's pretty much it at the very end. And if this is now, usually sometimes depending on how you do it, you might also write, well, something else happens. Maybe process when the offset number is not in the set, but in this case you don't do anything, so that's why we'll pass. And then now all you have to do is answer.append current. Basically now current will have the mapped numbers, so you just do the current, and then at the very end you just return answer. That's pretty much how you would do a power set. Let's run it real quick. It looks okay. You could probably try to do more. I don't know, for this one we have to worry about duplicate numbers, so let me take a look at the, okay, there's no distinct integers. Okay, so we don't have to worry about duplicate situations. It looks okay, so let's submit it. Let's see. Okay, cool. Yeah, so that's how, I hope this was an introduction to how to do power set. And sometimes when you see people doing, you look at other people's code and they do this craziness with, all this bit shift and mask and stuff like that. Well, this is basically what they're doing. So the complexity is going to be dominated by this, but also there's this portion. So it's just 2 for loops that are independent of each other. So it's just 2 times n, n times 2 times n to the, so this is the complexity. The space complexity is also this thing over, n times 2 to the n roughly. And the reason is because that's just output sensitive, right? Like you can't really do better than that. Yeah. So what are the trade-offs of doing this versus recursion, right? Well, in this case, doing recursion is that this is much faster than recursion in the case where you need every single power set, because, well, you're not skipping anything anyway, so you need to do it every time. The for loops are cheaper in general than making a recursion and also handling whether you use the number or not or something like that. So it's gonna be faster than just putting stuff on the stack and allocated memory and stuff like that. So when is this slower than recursion? Well, this is slower than recursion when you don't need every power, you don't need every subset, right? For example, maybe you have a weird problem or a different problem where you want every power set, but you want it so that the 2 and the 4 cannot be true at the same time, right? Well, in here, maybe you would have some, you add some additional logic of, okay, if 2 and the 4 position is not true. Some filtering logic. But if you do it the recursive way, then you could have done it to begin with, so that it automatically filters out the entire branch of recursion, so that it does, it does it instead of just, doing it, trying every process that it's true. Let's maybe do another example where you don't want 1 and 2 to both have ones, right? Well, in this case, in this case where you try every possibility, it's still going to be n times 2 times, it's still going to be n times 2 to the n. But if you do it with recursion, it takes very little loop in the beginning to see that both 1 and 2 are taken. So then you just don't do a recursion on it, right? And well, how much time do you save in that particular case? Well, that means that there's n minus 2 elements here, and in this case it's just 2 times n over 2, right? So that means that you save 4. So this is 4 times faster because you skip all those element checks. So that's kind of a really quick overview of bitmask and generating a power set with bitmask. Let me know what you think. Let me know if you have any questions. If people are interested about it, maybe I'll do a video just on bitmask and stuff like this. Yeah, let me know what you think. Hope you had a good time. Hit the like button, hit the subscribe button, and I'll see y'all tomorrow. Bye bye.